In this video, we're going to transform an integral into a Riemann sum and use the properties of summations to evaluate that Riemann sum. So the question here is to evaluate integral 1 to 4, 2 minus x squared dx by applying the definition of right-hand Riemann sum. Let's start with the interval AB, which is equal to 1, 4. And let's form delta x, that's the equal partition width, that's b minus a, divided by n, that's 4 minus 1 divided by n is equal to 3 over n. Xk are the grid points. This is defined as a plus k times delta x. That's equal to, we know what the a is, that's 1 plus k, and delta x, we found it to be 3 over n. And k ranges from 1 all the way to n. So those are the x values. If you plot k equals 1, you're going to get x1 is equal to 1 plus 3 over n. And that is the first sample point. That's x1. If you put k equals 2, you get x2 is equal to 1 plus 6 over n. And that's the second sample point. If you plug, say, k is equal to n, that's going to give us xn is equal to 1 plus n times 3 over n. The n's cancel out. 1 plus 3 is 4. And that's the value of b, the endpoint. So there it is. That's b equals 4. All right. So our goal is to rewrite the definite integral a to b f of x dx as limit n approaches infinity, k goes from 1 to n, f of a plus k times b minus a over n times b minus a over n. Now this part here is f of xk. That's the functional values. This part is delta x. Alright, so we have a equals 1, b is equal to 4, delta x is equal to b minus a over n. That is 4 minus 1 over n, and that's 3 over n. We found our xk to be a plus k times b minus a over n. That's 1 plus 3k over n. Now, f of x, the function, is equal to 2 minus x squared. So let's substitute xk into the function. We get f of xk is equal to 2 minus xk squared. That's equal to 2 minus xk was found to be 1 plus 3k over n. So that's 1 plus 3k over n all squared. All right, so the integral from 1 to 4, 2 minus x squared dx is equal to limit n approaches infinity, k goes from 1 to n, 2 minus 1 plus 3k over n all squared times 3 over n. So all of this is Rn, the right-hand Riemann sum. And we're going to take the limit of Rn as n goes to infinity to find the exact value of the definite integral. All right, so let's simplify Rn and then evaluate the integral 2 minus x squared, 2 minus x squared dx. This integral can be evaluated by taking a limit as n goes to infinity of Rn. All right, so Rn is the right-hand Riemann sum. That's equal to k goes from 1 to n, 2 minus 1 plus 3k over n all squared times 3 over n. We need to do a lot of algebra on this, but before doing that, we need some tools first. So we know that summation 1, k goes from 1 to n, that's equal to n. Summation k squared, k goes from 1 to n, That's equal to n times n plus 1 times 2n plus 1 divided by 6. And summation k. K goes from 1 to n. That's equal to n times n plus 1 divided by 2. We need a few more tools. Summation CAK, C being a constant. K goes from 1 to n. The constant passes right through the summation and we'll get C. Summation AK. K goes from 1 to n. Also, if you have summation, K goes from 1 to n of AK plus BK, we can split up the summations. That's summation AK plus summation BK. K goes from 1 to n. K goes from 1 to n. All right, so the Rn that we have here is 3 over n, summation, K goes from 1 to n, 2 minus 1 plus 6k over n plus 9k squared over n squared. And we basically got that by squaring this term 1 plus 3k over n all squared. All right, and this is equal to 3 over n, summation, k goes from 1 to n, 1 minus 6k over n, minus 9k squared over n squared. All right, so what we have is Rn is equal to 3 over n, summation, k goes from 1 to n, 1 minus 6k over n, minus 9k squared over n squared. We're going to simplify this. All right, so what we have is Rn is equal to 3 over n, summation 1, k goes from 1 to n, minus summation, k goes from 1 to n, 6k over n. We're splitting up the summations, minus summation, k goes from 1 to n, 9k squared over n squared. So we get Rn is equal to 3 over n, and we know from one of the properties earlier that summation 1 is just going to be n, minus, let's pull out 6 over n, and summation k is going to be n times n plus 1 divided by 2. And now we're going to pull out 9 over n squared. It's a constant, passes right through the summation, minus 9 over n squared. And we get summation k squared, which we know to be n times n plus 1 times 2n plus 1 divided by 6. So we need to do more simplification. We have Rn is equal to 3 over n times n minus, the 2 cancels with the 6, we get 3, so we get minus 3, and the n cancels out, minus 3 times n plus 1, minus 9 over 6, and we get n squared plus n, times 2n plus 1, divided by n squared. Let's simplify a bit more. We get Rn is 3 over n, n minus 3n, minus 3, minus 9 over 6n squared, times 2n cubed. Let's add up the middle terms, so we get n squared plus 2n squared, that's 3n squared, plus n. Rn is equal to 3 over n times n minus 3n, that's minus 2n, minus 3, minus 18, n cubed over 6n squared, minus 27, n squared over 6n squared, minus 9n over 6n squared. And all of this is multiplied by 3 over n. So we get Rn is equal to minus 6 minus 9 over n minus 54 over 6, n cubed divided by n cubed, minus 3 times 27, n squared, over 6n cubed, minus 27, n over 6n squared. All right, let's do a bit more simplification. So what we have is Rn is equal to, I'll rewrite it from the last page, that's minus 6 minus 9 over n, minus 6 minus 9 over n, minus 54 over 6 is minus 9, that's going to be minus 9, and minus 27 over 2n, minus 27 over 2n, and then we get minus 27 over 6, minus 27 over 6n, minus 27 over 6n. Now we're going to be taking a limit as n goes to infinity. So let's take the lim as n goes to infinity of Rn. That's going to be the limit as n goes to infinity of minus 6 minus 9 over n, minus 9 minus 27 over 2n, minus 27 over 6n. Now, when we take a limit as n goes to infinity, it is clear that 9 over n, this ratio will approach 0 because we have a constant being divided by a large number. Similarly, 27 over 2n, this will go to 0, and 27 over 6n is also going to go to 0. So the limit as n goes to infinity of Rn will be minus 6 minus 9, which is minus 15. All right, so the integral from 1 to 4, 2 minus x squared dx, this definite integral has a value of minus 15. So what we're going to do is we're going to graph the integral 1 to 4, 2 minus x squared dx. We're going to graph this in terms of what we have here. So you can see that negative 15 is actually the net area. So if I call this shaded area A1 and this shaded area A2, then the net area will be A1 minus A2, that's equal to minus 15. And that's the integral from 1 to 4, 2 minus x squared dx. That's equal to minus 15. All right, thanks.